Hello there, welcome to this video where we will be deriving the present value annuity formula, and this is usually used in terms of loans or paying off some debt, or if one gets an inheritance because the money will be available now or at present. Okay, just like when somebody gets a loan from the bank, money is available at present. What we see here is the same variables that we saw in the future value annuity formula, but now we've got a negative n, and this really speaks to the fact that here we are backdating payments, because interest has to accumulate first, then the payment must come in after that. So in this case, here's our timeline, and I've indicated the details there that X payments are coming in. Payments of a value of X are coming in for n number of payments in this financial cycle. So what we have here is the present amount of money. Whatever amount that is, what will happen is that then we will then accumulate interest, or it will accumulate interest for one payment cycle, or that can be 1 month, and then a payment comes in. So we need to backdate that X 1 month earlier, and then the next payment comes in month 2, so we need to backdate that X 2 months earlier. So all the way to P, right? That is what we're doing to each payment that comes in 3 months. The negative n there. That is how it is operating in the background when one performs that calculation. So instead of taking each X and backdating it with n being 1, 2, 3 individually, which can be a tedious process, we can remember that this whole section here actually represents the fact that if we make this payments all the way to n number of payments, we end up with a future value. So instead of backdating each payment, we can take the future value here and backdate it all the way to the first month after interest has been accumulated. So in other words, present value is equal to the future value times the interest accumulated over this number of payments that should be made to pay off this particular debt. We know the formula for the future value now. It is X into 1 plus I to the power n minus 1 over I, and we're multiplying this by 1 plus I to the power negative n. What will then happen is we can end up with X times 1 plus I to the power of n times 1 plus I to the power negative n minus 1 plus I to the power negative n over I. Well, as you can see, it's a product of powers of the same base. You can add exponents, that will give us 1. 1 plus I to the power of 0 will give us 1, and this will be X into 1 minus 1 plus I to the power negative n all over I, which represents our present value annuity formula. Should not have cancelled there. I was just showing you that the n minus n gives us 0. So the basis remains intact. It's 1 plus I to the power of 0. So let us not misconstrue that there. So yes, this is the derivation process that gets us to the formula that we can now start applying in different contexts to now understand where it comes from and really what it means, where we take payments and we backdate them. Instead of taking individual payments, we take the future value and we rather backdate that and tell us exactly how the formula, and it tells us exactly how the formula should look like. So this takes care of this particular video. Hope that you gain value, and if you need to, you can definitely rewatch this video, and hopefully it will make much more sense and bring some clarity in your understanding. Thank you for watching. See you in the next one.